Welcome to another PanMesh tutorial session. In this session I'm going to demonstrate how to create a partially communicating two-layer model and then how that can become a non-communicating two-layer model. So we begin as usual with this base example. Just to note that this could be any pan system file where there isn't a PanMesh model already built in it. So we begin by clicking on data preparation, well reservoir and fluid description, numerical model as usual. Simply click on rectangle and I actually get a square model of uniform thickness. And what we'll do is we'll set immediately the dimensions of this. Let's make it 1500 by 1000 and 100, let's say for the moment 100 thick. Okay, so we have a model now, and if we look at model check, we'll see that again, as usual at this stage, the model is complete except for the perforation or completion data, which is set in here. Before doing that, what we will do is we will add two more layers. Now, I did indicate at the beginning of this session that we were going to build a two-layer model, partial communicating and as well as then non-communicating. But in order to do that, we're going to create a thin layer in between the two main layers that we're concerned with. So what I will do is I'll go to reservoir node and layer configuration, and I will click on this layer here and then simply click insert layer twice, in fact, and you'll see that we now have three layers. I'm going to make this intermediary layer only, for argument's sake, 2 feet thick. So I enter 2 here and I click on apply thickness to all nodes. So now I have a very thin layer sandwiched between two normal or standard layers. That's fine. Now let's imagine that we've got a scenario where we've only got completion in the top layer and that there's only partial communication with the bottom layer. So in order to do that, we need to create a new material property of low permeability, or arguably, if we like, just low vertical permeability, but we'll make it isotropic and low permeability. So we go to material properties and we go to new. So we've got a new material and the values are parameter values are empty for that material when it's just created. So as a starting point, I'll copy the material properties from material 1 and I'll paste them to material 2. And then what I'm going to do is make this a low permeability, isotropic as I indicated. So now we've got two materials. And now I'm going to put that material 2 into the layer that separates the top and bottom layer. So I just click here and enter 2. And now I have that low perm material in there. I'll also remove the skin, which was inherited from the underlying pan system file. That we have no skin damage, just to not complicate the issue. And what I'm going to do is I'm going to say, well, let's imagine a scenario where we've got the top layer 25% complete, so 25 feet out of 100, separated from the bottom layer, which is also 100 feet thick, by this thin low perm layer. So it's only partial communication. So if I look at that on my data, my model is complete. I can confirm in this reservoir geometry view that in fact I have got 3 layers with the low perm layer in the middle, so that's layer 1, layer 2, layer 3, and of course this is region view, so if I go to show materials, layer 2 is showing as material 2, and layer 3 is back to the material 1. So the model is complete. If I now click on simulation, numerical simulation, PanMesh new run, I get my model. Let's have a look at my model. Now I can just about make out there that I've got this thin layer. So what I'll do is two things. I'll take a cross section and then I'll zoom into the wellbore by clicking this button here. And it zooms into the completed section of the wellbore. I'm going to zoom back out by clicking shift and right button down. And I'm going to pan it by keeping shift pressed and left button down. And now I'm going to, so we can see clearly, we can see this line, but we see a double line because the reservoir is being shown as translucent, or the light is coming through it partially. So let's set the transparency to opaque. Now we can clearly see the line here depicting the low perm layer. So what we want to see is the effect of that. So let's just run the simulation by either pressing F5 or clicking on run simulation. The simulation runs pretty quickly. So what are we getting? Are we seeing anything telltale? Sort of see a partial completion bump there, something happening here, but maybe not significant enough. Maybe our communication is too high for the moment. You can see the effect here. If I go to radius investigation, you can see it maybe a little bit clearer. So the pressure transient comes down, reaches the low perm layer, gets blocked off a little bit, then it starts to break through the low perm layer, and that's where I indicated here I could see a second bump on this curve, and it continues on, and then it essentially gets in at this stage to almost radial flow, but it's touching the outer boundary. So in this example so far, we've seen how to have or create a model with partial communication. We could play with this and drop the communication further and see what kind of effect we get on the curve. But for the moment, what we'll do is we'll just show how to create a non-communicating model from this original model. So I'll close this. We won't interpret the curve in pan system. We'll just go back to our model. And what I'm going to do here now is, remember I have got this region, or this layer, should I say, of low perm. I can remove this layer completely simply by going to select and right clicking. And now I have removed the layer completely, so it's not any longer a partial communicating system, it's two non-communicating layers. Now what this will do, if you think about it, if we model this, is it will just run as if we've got a single layer 100 feet thick, and because there's no communication neither in the body of the reservoir or in the wellbore, we will not see any input from the lower layer. So let's run that. If we look at our model, you can just about see, let's see, what we'll do is actually again take a cross section, zoom in, zoom back out a little bit, and here you can see I'm going to again make it opaque. We zoom in there, you can see the light out the back. There is no communication between the top and the bottom layers, and we'll see that even more markedly if we actually run the simulation. And the first thing you note here is, look at the derivative curve. We're getting here a section of radial flow, but the radial flow is apparently occurring at a derivative value of 1, whereas normally it would be 0.5, and that is because the thickness that the non-dimensionalization is using is the overall thickness of the reservoir, whereas the simulation is only feeling activity in half of it, and therefore that's why the non-dimensionalization is coming out at a value of radial flow at 1. If we look at the color contouring, we'll see it even more markedly. That if we zoom back out, you'll see that all of the pressure transient changes occurred in the top layer, and there's nothing at all happening in the bottom layer. So if we go back in time, we'll see that it's just acting as if it's a layer 100 feet thick. So we can get it to communicate. If we go back in here, we could put a second completion. So let's say that there's 2 completions, and we put the second completion at a depth of maybe 150 and make it 10 long. Check the model, that's fine. Come back, run our simulation. Now if we look at the wellbore in top and bottom, you can see the white section here, white section at the top. We'll run our simulation, and now we'll just basically see a curve that is essentially the same as if it was communicating, and our derivative is closer to the 0.5 as it should be. If we look at the color contouring, see the pressure transient going out in top and bottom layers. What's interesting there is that because there is no communication, we're not getting a smooth or uniform radius of investigation in the top and bottom. They're slightly different because the completion length in either section is different. So we can, with this model, obviously change the permeabilities, have different permeabilities in the top and bottom layer, etc. So that's an example of how to create either a partial communicating 2-layer system or a non-communicating 2-layer system. Thanks for your attention.